Good. Okay. So then the next thing is I was looking at some of the comments. So just to be clear, even though there are 3 lectures that have been uploaded, but those are 3 lectures of the same topic. Okay. So it is not, don't think that there are 9 topics and we have shared the video of 3 topics. Till now we have only uploaded for 1 topic, even though there is lecture 1, lecture 2, lecture 3, all the 3 lectures belong to the same topic. So you will get 9 such sets of videos. Sometimes it will be long, sometimes it will be short, but basically it is just one. The first group of videos, there will be 9 such groups. 3 lectures does not mean 3 topics have been covered. Now, next is the first topic is perhaps the most important topic in this course. So make sure to watch all the videos, make sure that you understand all the concepts properly. If you understand the first problem sheet perfectly, then the second, third and fourth will not be difficult for you. First, second, third, fourth are interrelated. All of them are built on whether or not you understand the first topic well enough. Okay, so please keep this in mind. Make sure to watch the videos. Make sure to understand this completely. Otherwise, problem sheets 2, 3, 4 will become very difficult for you. Okay, good. So now I am sharing a presentation. Basically, what I'm going to do today is I have selected 5, 6 questions. We will discuss the questions. I want to know whether you would be able to solve those questions by yourself or not. Okay, yes, so it's visible, correct? So look at this question, and is a PowerPoint visible to everybody?
Yes, sir.
Yes, sir.
Yes, sir.
So
Sir.
look at this problem was also given as a part of your lectures. Now, first of all, look at the figure carefully. What do you see? You see, first of all, that there is a point and there are 3 forces in that. I'm sure all of you know that force is a vector. Yes?
Yes, sir.
Force is a vector because it has a magnitude and it has a direction. Now, in this figure, the first thing you should notice is that there are 3 methods given as to how the direction of a force can be specified. The first is most common, where angle is given directly. Okay. The second is where a right angle triangle is given, the base and the perpendicular is given. When you approach situations like this or this, then it is straightforward. The third one, the angle is not given in a straightforward manner. That you have to calculate using geometry. Can anybody tell me what is this angle, which I have drawn by 2 lines?
37 degrees, sir.
45 degree.
It is
Degree, sir. 45 degree.
45 degrees, because the 0.1 plus 0.3 is 0.4. 0.4 is both the base and the perpendicular. So it is 45 degrees.
No, sir. No, sir. No, sir.
Tan inverse 2.
No, sir.
It's tan inverse 2.
Correct, you are right.
It's
It is
tan inverse
tan inverse
Tan
Tan inverse 2.
It is tan inverse 2. Yes.
Yes, sir.
Yes, sir.
Yes, sir. Tan inverse 2.
Tan inverse 2. It is 0.4 is measured from this point.
Yes, yes.
You want this length. So this is 0.2. So you are going to encounter there will be some problems where the trick is going to be how to find the angle, especially in problem sheet number 4 when you are looking at frames. So please brush up your basic trigonometry and you should be able to visualize and be able to calculate angles. In 2D it is straightforward. In 3 dimensionals it might not be so straightforward, but ultimately you will need the information about the angle, and the angle can be provided in any one of these 3 ways. Now, if these 3 angles are known and if the x and y coordinates are known, can you find the x and y component of each force?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
I am quite confident that all of you can do be careful that the x component of f
Sir,
will be
sir, a
negative.
suppressor useful.
Yes.
Yes, sir.
Do you want to say something?
No, sir, I actually unmuted accidentally.
Okay. So, but while writing the x and y component, you have to be careful that some x or y components can be negative. So please look at this and tell me which components of force will be negative.
Sir, F2, F3, Y
X
component will be
coordinate of
negative.
F2
Sir,
and
X
Y
component
coordinate
of
of
F2
F2.
is
And
negative
F2,
and
X
Y
component
component of
F2 X
F3 is
component and
negative.
F3 Y component.
F2y, F2y.
F2 X component.
2x
Sir.
component and
No, sir.
F3 y component.
F2 X component.
X component of F2 is negative and Y component of
F3Y.
F3 is negative.
Is this right?
Yes, sir.
No, sir. No, sir.
F2X component.
Exact
F2
opposite.
X
F3Y.
X and
No, sir,
Y.
F2 is X
Yes.
component.
F2X.
F2 X and
And for
F3Y.
F3, it's Y.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
First, okay. So this is easy, but make sure that you understand these things well. Now, look at the figure at the top right hand corner. And now, if I tell you that you have to calculate the moment of force A from about point O, how will you do it? First of all, what is the direction of R cross F?
K cap.
Sorry, inside the plane.
Inside the plane.
Perpendicular
In the plane of the
Inside the plane of paper.
Okay. Correct. So R cross F is mutually perpendicular to both R and F. Correct. Correct or not?
Yes, sir.
Yes, sir.
Now my question to you is, physically why is that happening? Can anybody explain? One at a time. Please raise your hand if you want to explain. Why is the moment about a point perpendicular to both R and F? Why? So Mohammed Shahriar wants to answer, please.
Yes, sir. Yes, sir.
Yeah, tell us.
Sir, because
Why?
moment is cross product of position vector and force vector. So
Why? Why?
Direction
From
of cross
physics
product.
you can no, but that is all mathematical, na? Cross product. It is. You are. I want a more physical explanation. What does the moment about a point signify, and why is that perpendicular to both force and moment? So yeah, there are a few more people. Who wants to go next?
Sir, perhaps sir, it is the direction of in which the screw progresses.
Sony, Aditya, you want to try?
Yes, sir. Yes, sir. Basically, it's torque. The direction of torque will be the direction of angular acceleration, which will be produced by force. So, if we look at this system, then the force produces a turning effect, and the direction of the turn we can be is paper angular acceleration.
That is all. That is correct. So I am actually stopping the share to show you something. Yes. So look at. Imagine that you have a book. Keep a book at the ground. Am I visible?
yes, sir.
Yes, sir.
Imagine that you have a book. Imagine that you have a
No,
book
no, sir.
and you are holding the book
No,
from
sir,
one
you are
side.
not visible.
And now, if
You are
you
not
apply
visible.
force, in plane force
Sir, you
at
are
one
not
of the
visible.
edge, what will the book do? The book will have a
Sir, you are
tendency
not
to rotate.
visible.
Yes.
Yes, sir.
Yes, sir.
What is the axis of this rotation?
Vertical.
Perpendicular to the book.
Exactly. So when we are calculating moment about a point, this is what we are trying to do. Clear? That is why force
So can you explain again,
moment is
please?
going to be perpendicular to the force and the radius.
So can you please explain again?
Okay, so my point is, imagine that a book is lying in a plane or you are holding to a book from one corner. I should normally be visible. I can see myself. So I think something to do with your setting, Tanmay
You
and
are
Anurag.
visible, sir.
Yes, sir, you are visible.
So imagine that you are holding a book from one corner, or that book is lying on the ground. That's also fine. Now you are applying a force along the. How do I pin myself? I think you have to pin me, then you can see.
Yes, sir. Now you are visible.
Okay, so now if I hold the book at one end,
I have pinned you, but I can't see. It's coming only A.
I think poor internet. But basically, even without looking at me, you can understand. Try to hold a book from one
Okay,
corner
sir.
and apply force in the plane of the book. Then your book is going to rotate. And that rotation is perpendicular to both the force and the paper that you have and the paper of the book. So basically, when we are calculating moment, this is what we are trying to do. That this is a practical example of why moment should be perpendicular to both the radius and the force. Clear? Now the next question is, do you know how, I'm sure all of you know how to calculate the direction of a moment. Yes, all of you know what is the right hand thumb rule?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Okay. Let us share again. Let us get back.
So now you are visible.
Okay. So vector mechanics. No, sorry. So where is my presentation? Share content. Yes.
Sir, I have a doubt regarding moment and torque.
We'll get to that. That is a very valid question, but that is going to come later also. Don't worry.
Okay, sir. Okay.
Okay, so now I am looking at this. Now we have to, there is a force A whose magnitude and direction is given. Now we want to calculate the moment about point O. What are the different ways by which we can do this? First is we can calculate the perpendicular distance between point O and the direction of the force, and I can do F cross D. Or I could decompose the force into x and y component, cos and sine, and then I can calculate the moment. So basically it is going to be F1 into this length, F2 into this length. Okay? Or we also know that forces have this condition of transmissibility. So I can take my force to a point such that it is passing directly over the point O. In that case, F2 component will not lead to any moment. It will be F1 into OB, or similarly F2 into OC. So there are actually 5 ways. In fact, there will be many more ways when you think of it on how you can calculate a moment about a point. And none of these 5 is wrong, and there will be absolutely no reason to prefer one over the other in a general sense. It all depends on what problem you are trying to solve. In this course, there will be no marks for using a specific method. If you had to calculate moment about a point, you could do all 5 or any one of the 5, all would be correct. So our mechanics is very open-ended that way. But it is nice to know all the different methods, because in different contexts, different methods will be much easier. So is the 5 different options of calculating the moment clear? This is also explained in the video by Dr. Puneet Patra.
Yes, sir.
Yes, sir.
Yes.
Yes.
So from this slide, please take home the message that there is no one specific right way of doing it. It is open-ended, and as you go deeper and deeper into your engineering, it is going to be more and more like is no only one right way of doing it. There are many ways. You have to choose as engineers, as students, which you want to do or which is more suited to a particular application. Okay, so now look at this problem. You have a nail and you want to pull it out using by tying it with a thread and trying to pull it from two directions. Now, can you determine the load P and the angle if net effect is a vertical force of 40 pounds on the nail?
Yes, sir.
Yes, sir.
How will you do it?
Yes,
Please
sir.
raise your hand if you want to explain how we can do this. Anurag Chakravarti, you want to try?
Yes,
Or
sir.
let us do something. Please try to solve it
Sir.
and write the answer in the message section. You can try. All of you, please try to solve this question. Write the value of the angle alpha and the load P in the message section. This angle is alpha. There are two unknowns. P is unknown, angle alpha is unknown. We need two equations. What are those two equations?
Sir, one is about vertical and another around horizontal.
Yes.
Sir, we equate the components along the vertical and the horizontal.
Along
It's the
vertical,
same
net
way.
force would be 40 and around horizontal 0.
Correct. So we
Yes,
first
sir.
thing we will do is
Yes.
we will so when you are trying to solve a problem like this, first thing you should do is you should choose an x and y coordinate axis system, which we have done. And then what is the answer?
Angle is 44.7 degree.
Hello, sir. Hello, sir.
Yes.
Angle is tan inverse 0.98.
Alpha is 44.7 degrees. Some of you have mentioned that is the correct answer. What is the value of P?
Sir, 18 pounds.
If you write 18 pounds, it will be wrong.
18.01.
I am
18.0.
18.02 pounds.
18.02, sir.
Yes, yes,
Yes, sir,
Sir,
18.02.
that means
yes.
when we feed into
18.02 pounds.
the computer,
Okay. This. So now let us look at another problem, which also I'm sure all of you have done today. We are just warming up. We have,
excuse me, sir.
yes,
Sir, in the previous problem, just for the sake of correctness, we have to look into the 0.2 that tolerance value.
so yeah, if you write somewhere between 18.01 to 18.04, it would be correct. Anything else would be wrong.
Okay.
18.00 to 18.04, that is the range that would be expected.
Thank you, sir.
And 14.68 to 14.72. Okay, so now a 90 Newton force is applied to control the rod AB as shown. Knowing the length of the rod is 225 millimeters and the moment is 13.5 Newton meter, determine the value of alpha. So the first thing is, as I said, one of the first decisions you have to make is choice of x and y axis. You have two possibilities. One could be that you are choosing your x and y something like this, let us say. So parallel and perpendicular to the rod. This is one possibility, and the second possibility is this. So which do you think we should use?
A, sir.
So the first one.
You should use this is a more convenient coordinate axis.
B.
So let us try to do this, and then we try to decompose this 90 Newton to two components, one along AB, one perpendicular to AB. So you should have something like this. Yes or no? Now look into this figure, and then what is my moment equation? What is equal to 13.5? Q. Several people have given a question. Daksh, Abhijit, Anubhav Mandal, Tanmay Datta, Deep Tavadas. Any one of you have some question?
No, sir.
Okay, so please look into this and tell me what is equal to 13.5 based on the diagram that I have shown in the bottom.
Cos alpha plus 25
19 cos alpha plus 25.
into 0.225 is equal to 13.5.
So Q into 0.225 is 13.5, correct?
Yes, sir.
And
Yes, sir.
Q is equal to 90 into cos alpha plus 25. Based on this, you can solve it, and the correct answer is alpha should be equal to 23.20 degrees. Let us look at one more interesting problem.
Excuse me, sir.
Yes.
Sir, please ask others to mute themselves. It's very difficult to hear you.
Let me mute it. I will mute it. Okay, now I muted everybody. So where were we? We were in this slide. Please read this question and try to solve it. A 300 Newton force P is applied at point A as shown. Compute the moment of the force P about O by resolving P into vertical and horizontal components. First step. And second step is using the moment that you have calculated, calculate the perpendicular distance between O and the line of action of P. Please try to do this, and once you get the answer, please put it in the message section. Shampura, do you have a question? Please unmute yourself and you can ask. No? The first thing is, now we want to find out what are the x and y components of vector OA. Calculate that, calculate the x and y component of P, and then you should be able to calculate the moment. What is the x component of RAO? Please write down. Please type in the message. If you have finished in that level, what? How can we break the R vector into x and y components? What is the x and y component of vector RAO? Does everybody get this?
Yes, sir.
The F component, the x and y component of the forces is straightforward. So it is 300 sine 30 and 300 cos 30. Now you can calculate the moment.
Sir,
Yes.
sir, I have a doubt that by horizontal and vertical components, do we have to align along this axis of OA line or like perpendicular to with the page like that?
Up to you. Both ways you will get it right. I have aligned it, I think, along. In this problem, I have aligned it along.
Parallel to the floor.
Yes.
Okay, sir. Thank
Both
you.
would be right. I think either way you should get the correct answer.
Sir, is this
I also have a doubt.
sir, is
Yes.
the structure massless?
Yeah, it is massless. So unless otherwise specified, you will ignore the mass and friction. If you have to take friction into account, if you have to take mass into account, it will be measured very clearly.
Excuse me, sir.
Sir?
Yes.
Sir, it's given horizontal and vertical components. So I think we should
Okay,
take
yeah,
that.
it is clear. If it is written horizontal and vertical components, then you take horizontal and vertical components. This is the correct answer.
Sir?
Yes.
Sir, for in between, if I get some answer like R, I'm getting 200 by 1000 cos 40 I cap plus 7 sine 40 J cap, and everything I'm getting in the last part after doing some calculations, I'm getting cos 70. Can I directly substitute the value of cos 70 there instead of
that is good practice. What you are saying is good practice.
Okay, sir.
As long as possible, so keep this tip in mind. In mechanics problem, you should always try to delay putting the value of constants as much as possible. The more you delay, the more accurate your answer will be. So while solving it in the first or second time, you will try to put the value of constants in the first step or in the second step. But the more you delay, the more accurate your answer is likely to be. Okay?
Okay, sir.
Somebody is asking me
Yes,
that
sir.
they don't understand the second part. Okay?
So please explain the angle near PA.
Which angle?
So near PA, the 30 degree.
So P is at 30 degrees with the vertical. That is the 30 degrees. So yeah, basically P is at 30 degree with the vertical.
Okay, sir.
Now, how do you find out the distance between O and the line of action of force P? So you know that FD is equal to M0 because M only has one component here. So we can say F into D is M0 and then you can calculate. So your value of P is known 3000, M is 20.5. So 20.5 is equal to 300 into D, where D is the distance between the line of action of P and point O. From there you calculate, D comes out to be 68.44 millimeters. Tanmay is asking, sir, I don't understand what delay in our solution for accurate answers. I was saying that you should delay putting the values of, for example, P is 300 Newton. You want to try to derive your solution as far as possible in terms of P. And only when you are looking for the final answer should you put the value of P as 300 Newton. Clear? Yes, Abhay is right. So you want to delay putting the value of constants as much as possible. Karthik, your answer is wrong. Please check. Okay, clear? Everybody understands this type of problems? I think you should have done problems like this in your JEE. Only here we are looking at more practical examples. Can I go to the next problem? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now this is a very practical example. So imagine that in this problem, what is happening is that you had a rod which is about to fall down due to some reason, and you want to make it straight. So what did you do? You hooked it and you apply the force here. And as you apply the force, the tension in this cable will increase. And after some time, you are hoping that this incline becomes straight. Okay? This sort of engineering is very common, for example, near a river bank or something where some electricity pole has started to fall down. This is a very common thing. This instrument is known as a winch puller. So AB is a winch puller. You are using it to straighten a fence post. It could be a fence post, it could be an electricity line, it could be anything. We know that the tension in the cable is about 1040 Newton. Length D is 1.90 meter. Determine the moment about D. We want to calculate the moment about this point exerted by the cable due to the force in this cable. By doing two things, you can either decompose the force into two components at point C, or you can decompose the force into two forces at point E. Is the problem statement clear? I am writing yes or no. If the problem statement is clear, just hit like on yes. If it is not clear, hit like on no, and then I can explain again.
Sir, are D and E on the same level?
Yes. Okay, so there is at least one person who has not understood this problem statement. So in this, I am assuming that this is, no, there are more than one student. Okay, let me explain again. So imagine that this is some sort of a river bank where you cannot stand at D to make it straight, but you have to make it straight somehow. So one of the common things we try to do is we will hook the inclined member, and then using a device such as a winch puller, I will try to press this lever at A in this direction. What it will do is it will try to increase the tension in this thread. And as you increase the tension in the thread, this has a tendency to become straight. Now in this problem, it is told to us that the tension in this thread is 1040 Newton. This length D is 1.90 meter. We want to calculate the moment that this tension is creating about this point D, because this moment is going to give us whether or not my object CD is going to rotate. So we want to calculate how much moment am I actually getting. So clear now? Please try to solve this. 4th class Sudesh Kumar, do we have a question? You have, okay. So please try to solve this. My suggestion is try to draw only this member CD, try to draw all the forces and try to neatly able to understand what the different distances are. First step, you should try to do that. It will come out to be something like this. So it is according to this figure, what I've done is this member CD is drawn here. TABX, TABY are the two components of force. This angle was derived based on the geometry. 0.875 divided by D plus 0.2 is your angle. So based on that,
Sir?
Yes.
Sir, what is 0.2?
0.2 is this distance, the horizontal distance between C and D. CD is not a straight line. Yes, CD is at a slight incline.
Thank you, sir.
So what is the moment? Can I say TABY into 0.2 plus TABX into 0.875? Correct or not? If you have got the answer as 760, it is right. Please try to solve it. I want confirmation from at least 5, 8, 10 people that these problems like this are very common. If you cannot, this sort of problem you should be able to absolutely master.
Sir, what is the allowed range of error?
It is 0.02.
Okay.
So instead of 760, 759.98, 760.02, both are okay.
Sir, is 160 the answer?
760 is the answer. 760 Newton.
Yes, sorry, sir.
Only Priyansh Singh in the message has written the units correctly. Everybody else has written only the numerical values. Please be careful. You are expected to write the number and the units. Well done, Priyansh. Okay, now look at this and try to check whether your answer is correct by repeating all the calculations based on calculating moment by decomposing the forces around E. Please confirm that you are getting the same value or not. And this is also very important. So saying 760 is not enough, 760 Newton meter is also not enough, 760 Newton meter anti-clockwise, that is the complete answer. So you can either write anti-clockwise or you can put an arrow showing an anti-clockwise saying that it is which means that it is anti-clockwise. Usually we will take anti-clockwise to be positive. Please try to solve by taking the components of force at point E and make sure you get the same answer.
Sir, what was the second part?
Second part is that instead of decomposing forces at point C, you should try to decompose the force at point E. Normally the value of the moment should be same.
We have to calculate about point D again.
No, about point D. So you are calculating the moment about point D at both the parts, but you are decomposing your forces at different points, at C and at E.
Okay, sir. Thank you.
Now this problem can have multiple variants. This is a very interesting problem because it can be twisted in many ways. For example, it could be that if D is 1.90 and we need a moment of, let us say, how much was the moment? And we need a moment of about 900 Newton meter anti-clockwise. So what is the tension that should be there? Or another way of twisting this question could be that the maximum tension that I can give to my member CE is 800 Newton. So what is the minimum distance B that I have to use? All of them essentially will require the same calculations, but in every time the unknowns can be different. The unknown could be D. What is the D that you prescribe so that we are reaching the necessary moments to make it straight, such that your capacity of tension is above a certain limit? Or what is the tension that you need to give if D is known and the final moment is known? In all the time, basically, if you have drawn this figure correctly, then you are in a good position. Okay, understood? Yes or no?
Yes, sir.
Yes, sir.
All the different variants can you solve?
Yes, sir.
Good. So all of these were 2D problems. Okay, in a 2D sense, you are calculating moment. I mean, you are doing something related to the moment, trying to calculate different unknowns. The unknown could have been D, the unknown could have been the moment, or the unknown could have been the tension. Now, let us look at a three-dimensional problem. Raja Newton is capital N. Okay, Newton was a very great scientist. The least we can do is, if a unit is named after him, we should use capital letters. So, problem number 7. This is a three-dimensional problem. Now, why we study three-dimensional problems? We study three-dimensional problems because, I mean, why in this course it is there? In this course it is there because sometimes getting a good visual understanding of the figure is not intuitive. Sometimes you get it, sometimes you don't. But if your concepts of vectors are clear, then normally even without a proper intuition of the shape, you should be able to get it. So some practice for 3D problems is also very important, I think. And the more complicated problems are likely to involve 3D. So now there is, in this problem, there is a bent plate, and in this bent plate you have If we remove the cable, these are the two forces on the bent plates. Yes or no? If I remove the cable and I am just trying to look at the forces it is causing at my bent plates, is the force that I have shown, is it right?
Yes, sir.
Okay, now we have
Yes,
to
sir.
calculate the moment of the two forces one by one. What do you think will be the relationship between the force, let's call it the moment that force FA causes and the moment that force FE causes? Will they be equal? So I am giving you three options, okay? Equal, equal and opposite, not equal. What do you think you can
So equal and
like?
opposite.
Equal and opposite.
Like
Sir, equal and opposite.
correct.
Sir, because
Sir,
the string is same, sir.
Equal and
equal and
Equal and opposite, sir.
Because the perpendicular distance is same, so magnitude will be same but opposite in direction.
Right, very good.
Yes.
So can you calculate what is the moment? And this time in the 2D problems, for us M0 was a number. It was understood that the direction is perpendicular to the plane of the paper. But in this case, now when you solve this problem, you should get three components of the vector. Please try to solve this problem. The first thing I would suggest to do this is O is the origin, write the coordinates of point A and write down the coordinates of point E. And then you can do, and then find out the direction of the vector AE. Then you should do R cross F to get the vectors, to get the value of your moment. What is AE in vector format? Please write down in the message. Let us see who is the first one to get it. AE is equal to X I cap plus Y J cap plus Z K cap. What is the value of X, Y, and Z? All of you are writing 210, 160, 120. Is that right, or should you look at unit vectors? Because the force is along this direction, right? So the magnitude of the force will be 435 into unit vector AE. That is right. So Grace is, I think, correct. Prodipto is correct. What is vector AO? RAO. That will not be a unit vector. So the what in vectors, the force FA is 315 I cap minus 240 J cap plus 180 K cap. Can you confirm? Is that right? FA is equal to 315 I cap minus 240 J cap plus 180 K cap. I'm writing the FA. Please confirm that all of you are getting this. It is 315I minus 240J plus 180K. Of course, this is you.
Yes, sir.
Yes, sir.
Actually, no, sir, it is wrong. Now it is right, I think. And AO is 0.09 I cap plus 0.16 J cap, everything in meters. Then can you find out the value of MO?
Sir, vector is 192 I cap plus 108 J cap minus 192 K cap into 15 into 10 ki power minus 5 Newton meter. Newton meter.
I have projected the answer. Please confirm that it matches with this. Okay. Gorti, Abhirama, Yogesh, what did you not understand? What should I repeat?
Sir,
Yogesh,
how to calculate
how
moment
to?
at A?
Yes. So what you will do is you need to calculate the coordinates of point A. You need to calculate the coordinates of point E and calculate unit vector along AE based on the coordinates that you have calculated into AE, multiply it with the magnitude of the force, which is this. Or like HSS, you can also take direction. Clear? Calculate the coordinates of A, calculate the coordinates of E, and then calculate unique vector along AE, multiply that with 35, then you get the force FA in vectors.
Sir, I'm getting the answer.
Okay.
Sir, got it.
Yes, sir.
And please confirm that at corner A and corner E you are getting negative.
Yes, sir. Got it.
Good. Okay. Now the next question. Can you determine the perpendicular distance of point O to the wire AE based on the answer that we have just got?
Yes, sir.
Right? What is the answer? Tell me. Madan, Yogesh, Gorti, Abhirama, it is clear now? Or should I explain again?
Yes, sir.
Okay,
Yes, sir. Is clear.
good. Who is this?
So, what was the value of M10? What's the value of the force? The
443. The correct answer is 100.765 millimeters or 100.77 millimeters.
Sir, I have a question.
Yes.
Sir, we can get answers in different units. For example, length can be answered in centimeters or meters or millimeters. So in each case, if we round it off to 2 decimal places, then answers will be varying on a much more higher scale.
No. Usually in such problems, it will be determine the perpendicular distance from point O to wire A in millimeters.
So units will be mentioned in the question.
Yeah. It will be done.
Okay, sir. Thank you.
The correct answer is 100.765 millimeters or 100.77 actually. How do we round off 765? 100.765 rounded off to 2 decimals is 100.77 or 100.76?
100.76.
100.76.
100.76.
Yes, so 100.76 is actually the correct answer. So just now somebody has asked a very relevant question that how do we finalize what place of decimal is correct? From an engineer point of view, can anybody try to explain? Like, I mean, is it depending on the mood that sometimes I will say 2 places, sometimes I will say 3 places? How do we usually decide how many units, how many places after decimals are
based on instrument?
It depends on instrument. Can you explain more?
Sir, because up till how many values means after decimal points, how many numbers we are getting the answer. That will be it. Sir, because some मतलब जो points होंगे उसके आगे कितना है और उसके पीछे कितना है, that we can't determine because of the limitation of our instrument.
Yes, that is right. So actually it will depend on how much accuracy you can measure. As an engineer, we only want to be as accurate as the measurements can be. If I have a measuring tape that can only go up to 0.5 millimeter, there is no point for me to get accuracy in microns because we will never be able to validate it. But on the other hand, if I am going to the lab and if I am looking at a microscope and measuring, if I can go up to microns, then I expect my numerical calculations also up to that accuracy. So usually the number of places after decimal has to be confirmed after having some sense of how these things are measured. So if you have a system like this, it is unlikely that you will go less than 100 of a millimeter. 1,000th of a millimeter is micron, and these things you are not going to really measure. You are going to measure this using a vernier caliper at best. So 100 places, 100th of a millimeter. If it was a more precise device and you were in the lab, you were looking at microscope, then maybe 100th of a micron, so on and so forth. So this is going to come from your engineering sense. As and more you know about how things are measured, based on that you will be able to make a judgment call as to how many places of decimal are correct. In this course, we will tell you how many places of decimals are needed. Okay, good. So that was actually the last. I have planned something for 1 hour. I think we can stop here because you have not looked at the video. So I'm hoping that you have only looked at video till lecture 2. So I discussed some problems of lecture 2. Any questions that you have?
Yes, sir. In lecture 3.
In
lecture 3.
Lecture 3, we'll look at it later. I mean, I don't think everybody has looked at the lecture. I was looking at the statistics. So far, only 50 people have looked at lecture 3 out of 70.
Sir, on Friday we will have 2 hours lecture, right? In general.
In general, Friday we have 2 hour not lecture but 2 hour tutorial. So the problem sheet that I have given, out of that 12 problems, we will try to solve 6 to 8 problems.
Okay, sir.
Problem sheet that you sent today will be discussed next Friday.
Yeah, so the idea is that you should try to solve all the problems that you can solve by yourself. The ones that you cannot solve, we will discuss on Friday.
Sir, is it important to maintain a fair copy of the problems that we do in tutorial sheets?
No, I mean, from my point of view, no, you are grown-up adults and I will treat you like adults. So it is up to you how you want to do it, when you want to do it. There are no marks for doing the problem sheets. But believe me, without doing the problem sheet, it's very unlikely that you will do well in the exam. So whether you keep a record, you do it neatly, or you just solve it, totally up to you. Different people have different ways of studying.
Sir, can you give us just an idea, like the difficulty level of exams will be almost similar to difficulty level of the problem sheets?
Yes, more or less.
Okay.
Tanmay, moment and torque, I will explain in the next lecture. So actually the question should be, what is difference between moment and torque? No, that is not the appropriate question. The question is, what is difference between moment, couple and torque? But that I think Puneet will explain better in your doubt clearing session on Thursday.
Sir, what will do in next hour?
What will be?
Do in the next hour from 3 to 4?
Up to you. I mean, you could look at the videos or you could start solving your problem sheets. From my side, this lecture is over. Today we were only planned for 1 hour because the problem sheet was only given today. From next Friday, we will have 2-hour tutorials. But today it is only 1 hour and it is over. So if you like to leave, I think the students who want to leave are free to leave. I have taken the attendance. This lecture is officially over. Those who have some questions or who want to clarify something, they can remain online.
Excuse me, sir.
Yes.
On which platform will we have the tests?
You will have the tests most likely on a platform named as Moodle. We are making your accounts. It should be ready in a week's time.
Okay, sir.
Excuse me, sir. Can you share the PPT?
Yes, I will share the PPT.
Yes. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, welcome.
Excuse me, sir.
Yes.
Sir, I had a doubt in lecture 2, part 1. About
yeah, but doubts, I think you have this dedicated class on Thursday. Now, next Thursday, the professor who has created the video, he will help you.
Okay, sir.
Excuse me, sir.
Yes.
Sir, why is 100.765 rounded to 100.76?
Because 6 is even number.
So if it's odd number, it will be rounded up.
Rule different for even and odd numbers?
It is just a convention. I mean, there is no reason for it. Everybody follows this. If everybody follows the same convention, then we are okay.
Okay, but why is it necessary to make the rules different? Why not the same for all even and odd numbers?
I don't know. To be honest, I don't know. But I mean, in engineering, you will see all sorts of sign, and then you'll ask why anti-clockwise is positive, why clockwise is negative. It is convention. What can we do? Why there are 60 seconds in a minute? Why not 58 seconds and we divide the seconds into such halves, such that why don't we divide a minute into 58 equal halves?
Sir, I have a question. Whenever there is subjective tests and we have to draw figures, so are freehand figures considered relevant, or we have to draw using a pencil and scale? Because till +2 level we were required to draw them using a pencil and a scale.
So if there are marks for figures, so most likely there will be marks for drawing a free body diagram. In your next lecture, which I am creating the video for, you will be given clear instructions on how to draw a free body diagram. There are some things that we will check. Whether you draw with a scale or whether you draw with a freehand is not important. But there will be few things we have to look at, which will be that whether or not you have drawn the XY coordinates, whether or not all the distances are marked clearly, whether or not all the forces are marked clearly. So there are other checks that you have to be careful about. But whether you use a scale, whether you are an artistic person or not, will not matter.
Sir,
okay, sir.
Should we write the units in the box also in assignments?
Yes, it is written with proper assignments where applicable.
Sir, along with the numeric part, the units should also be in the box.
Yes.
Okay, sir. Thank you.
Excuse me, sir.
Yes.
Sir, in your tutorial sheet, the value of G, we should take it as 10 or 9.8, sir?
No, definitely not 10.
Okay.
You can take 9.81 or 9.80665 or something like that. Please check.
Yes.
Definitely not 10. So somebody is asking which book should he use? Should he use the book by Beer Johnston or Merriam and Craig? So it depends. Actually, as a student, I have used the book by Merriam and Craig. Now, as a teacher, when I am teaching, I like to use the book by Beer and Johnston. The reason is that Beer and Johnston, the figures are nicer, the problems are slightly simpler. Merriam Craig is slightly harder. So depending on your appetite, you can choose one of the two. Sampurak is asking, how is our attendance marked? So as the instructor in your MS Teams, I am able to generate an Excel sheet with students who have joined the meeting. And I save that Excel sheet. So that Excel sheet, it marks clearly when you have joined, when you have left, what happened, all that log is maintained. If we get disconnected once, no. If you get disconnected, you come back. So basically it logs in that Sampurak joined at this time, left at this time, and then again he joined, etc. etc. So it should not matter. Shushmita is asking, do we need to submit tutorial sheet? No, you don't need to submit tutorial sheet. Tutorial sheet is for your practice to prepare you better for the exams. You only have to submit the assignments, and which problem is assignment, we will tell you very clearly. Pradipto, can you please provide us a scanned copy of only the exercise of Merriam Craig? No, Pradipto, that will be considered illegal. Willy Publications will come to me and slap me with a very heavy fine if I was to do that. And it has actually happened. So okay, anything else?